Welcome everyone. Let's go ahead and use the epsilon-delta proof to prove this limit. So we want to show that the limit of this function 5x minus 2 as x approaches 2 is 8. So you know by direct substitution this limit is 8, but we want to prove that by using epsilon-delta. So before we start the proof, let's write the sketch of the proof so that way we can construct the proof afterwards. So we want to show the following. We want to find delta greater than 0 so that if the distance between an absolute value x minus this number right here, 2, that is our a, if you remember the definition, this between x in absolute value x minus 2 is less than delta, then the distance between in absolute value, the function f of x, so this is your function f of x, 5x minus 2 minus L, this is L, 8 is less than epsilon. So if I were to rewrite all of these using the definition, here's your x minus a in absolute value, less than delta, and here is your f of x minus L less than epsilon. So we want to find delta so that this limit is 8. So let's go ahead and see that. So before we start, we want to make sure we start from here and figure out what is delta, because delta depends on epsilon. So let's do the sketch work. So we know that in absolute value, 5x minus 2 minus 8, this is equal to 5x minus 10. So we're just trying to figure out how to find delta. So you always start with your final statement and then work backwards. And by doing a little bit more simplification, this is equivalent to 5 times x minus 2. And here I can pull out the 5 from absolute value, you get x minus 2. Now notice that x minus 2 appears right here, and we know that's less than delta. So we know that this expression will somehow appear in our final statement. So based on this, we can say that we want, so let me just get rid of that. So here we want this to be less than epsilon, which means that now I can divide both sides by 5. So I have x minus 2, that expression is less than epsilon over 5. Now this is when you choose your delta, because we know that this expression from above is less than delta. So our selection for delta is epsilon over 5. And now we're ready to construct the proof. So let's go ahead and prove this. So when you're writing the proof, you always want to start off with given epsilon greater than 0, and then we want to choose a delta that depends on epsilon. So in this case, from our sketch work above, we know that delta we're choosing is epsilon over 5. And now we construct the proof. So we're assuming that x minus 2 is less than delta. Well, now delta is epsilon over 5. And notice that we wanted to show that the distance between our function f of x, which is in this case 5x minus 2, minus L, which is 8 in this case, we want to show that this is less than epsilon. But before that, let's notice what is this simplifies to. So this is equal to 5x minus 10, and that is equal to 5 times x minus 2 in absolute value, and that's equal to 5 times in absolute value x minus 2. So we're just backtracking everything we did earlier. And now, what is this equal to? Well, we know that this expression is equal to epsilon over 5, so I can substitute that in there. So we can say that now we bring in the less than symbol. Since that expression is less than epsilon over 5, we have 5 times epsilon over 5, and that is equal to epsilon. So we have shown that this is less than epsilon. So let's go ahead and write down one more statement. So thus we see that if x minus 2 is less than epsilon over 5, then we know that the function in absolute value 5x minus 2 minus 8 is less than epsilon. So by the limit definition, we can say that therefore the limit of this function 5x minus 2 as x approaches 2 is equal to 8. So that is how you construct an epsilon delta proof. I hope this helps.